Everything that you're going to hear stems from the fact that we cannot predict earthquakes. Because we can't predict earthquakes over decades or even minutes, we have to think in terms of likelihoods of occurrence. So we have to figure out the probability of earthquakes occurring, and from that, the probability of receiving strong shaking, and from that, the probability of damage to buildings, and from that, the probability of fatalities, injuries, cost of repair, and changed communities and lifestyles. This means that as we go every step, we take on more uncertainty. And it means that our calculations have to capture both what we know and what we don't know. This is very difficult to do. It's a complex undertaking, and it's even more difficult for people to understand these kind of results. Because there's no place on our hazard map, let's say for the likelihood of strong shaking in the next decade, where the probability is 90%. There's nothing more than maybe 30%, because our maps and our understanding is a very fuzzy, out-of-focus view of what the future will bring. So it's very easy for people to ignore us completely, because we don't know what's going to happen next. We have to teach people that given these uncertainties, this fuzzy image of the future is the best that we can provide and still enormously useful, because there are still some places with the highest risk and others where it's lower. And if we can provide this, people can prioritize their efforts to build stronger buildings and live safely. So what you're about to hear is the development of the tools and the results that allow all of that knowledge and all of that uncertainty to be provided to people in an understandable, actionable way. So I'd like to start with Paul Henshaw, who's our Director of Technology and Development, and who leads the IT effort, to talk about OpenQuake Suite itself.
Good morning, everyone. So I'm just very briefly going to introduce the OpenQuake software suite, introduce the various components and how they fit together. And then I'm going to hand over to our scientific coordinators, Marco Pagani, Victor Silva, and Christopher Burton, to tell you more about the hazard, the physical risk, and the social vulnerability aspects of the platform. And then we'll take some questions at the end of these four presentations. So what is OpenQuake? It's a suite of software components, open source software, for earthquake risk awareness and assessment. It's been built by JET in collaboration with scientific consortia, with regional experts, with sponsors, with partners. It's not just us here in Pavia, it really is an effort involving scientists and engineers all around the world. There are three main software components to this platform. There's the web-based platform, which provides access over the internet to data, models, and tools. We have the OpenQuake engine, which is a calculation engine for seismic hazard and physical risk. And we have a number of tools to assist in the construction of models for performing calculations with the engine and for collecting data to make better models. So how do these components fit together? The platform is the first port of call. This is where the users can find the data, they can visualize it, and they can search for it, download the tools, download data, download existing models. Then using the tools that they've downloaded and the data that they've downloaded, mixing in perhaps data that they already have locally, they can produce a model, run this model with the OpenQuake engine, and then we can share those results back on the platform for other people to use. So in particular, the results of a seismic hazard calculation can be used as the input for a physical risk calculation, And again, you can go around the loop. The results of the physical risk calculation can be used as input for a social vulnerability and integrated risk model. So there are different tools for different people, but the components are interacting to try and go. We have tools for end-to-end risk assessment. And we have these interacting software components to encourage and stimulate the interaction within the community. And already we have scientific consortia that have produced the data sets that are present in our model, in the platform, sorry. Most of the data sets in the platform were produced by international scientific consortia. Some of the people here are representatives of those consortia. We've also had models developed by regional programs. Again, we have representatives here today who have used these tools and used the engine to construct models and execute them, and the results of those, some of those are available on the platform now, others are a work in progress. So we have the components that interact, so the community can interact and work together. What is the current status? So we released the software for the platform at the end of last year, and we're celebrating the release of the platform today. And we will continue improving the software, the models, and the data, adding more models and data throughout the second working program of GEMS over the next few years. We released version 1.2 of the OpenQuake engine again at the end of last year. And we're already working on version 1.3. We expect to be releasing that in March. There'll be more information about that later on. We also have a number of modelling tools, some of which are available already, some of which are a work in progress. Again, the scientific coordinators will be talking more about that later on. I wanted to mention in particular the IDCT, the Inventory Data Capture tools. These are tools that were developed in a global component scientific consortia led by ImageCAD. Some of these tools are now being used in independent projects that are not led by GEM, that are not funded by GEM, and are kind of living a life of their own. We're delighted to see that happen. The IDCT guys will be in the booth in the library just across the courtyard here this morning and this afternoon, and I encourage you to speak to them to see what they're doing with these tools and how they're moving those projects forward. Just a few words about how we've developed this. We use open source software, we release our data with open licenses, but open isn't just about the license. It's about being able to see how the tools work, about seeing what are the assumptions that go behind our calculations, see really how those numbers, how the results are obtained. But also, you can see how we work. And making all of our software and our data available means that it's possible for other people to review, to help us identify problems, to help us resolve problems. And indeed, that happens. Our software, we review this internally, we have code reviews, but we also have some parts of the software contributed by people outside. For example, the ground motion prediction equations. Some of those were developed by people with local knowledge, contributed by people not in the GEM, not on the GEM staff. And we also have obviously the science board, external review, test and evaluation, and our sponsors. Many of our sponsors do provide not just funding, but actually feedback, have helped with comparing the results of our software and our models with their software to help us calibrate and review the software. So really, the openness is a tool for collaboration. And this really is it's much more than just releasing the software at the end. It's a way of working, and it's very important for us. It would not have been possible for us to build OpenQuake in isolation. So again, I'd also like to say thank you to all of the many people, the individuals, the organizations that were involved in making OpenQuake possible. So what are we going to do now? I've already said that we're going to be releasing the new version of the engine shortly with more risk calculators. We need to improve our logic tree support. And we want to make it easier to install, both for the large-scale cluster IT installations and for the smaller users for laptops. That's an ongoing goal for us. We will continue adding models and data to the platform and improving the visualization and the support for the user interface. I'm expecting we need more ways of extracting and exporting data for use with other tools. And the tools themselves, we will be continuing our development of the existing tools. We'll be releasing the Risk Modelers Toolkit early this year, and we will continue, as the data sets and the models evolve, we will need to evolve the tools to work with them. So, as I said, there will be more coming from the scientific coordinators. We also have our own booth in the computer room, again off of the courtyard, so this later on this morning and this afternoon. Please come and see us. We'll be running live demonstrations. If you have questions, comments, just want to see what we're doing, please do come and ask away.